today. So, now, solving systems of equations. Here we go, people. Let's get it together so we have time I can give you your test back today. Focus, focus. Now, there are three, I'm just not going to talk over you guys today. There are three methods to solve systems of equations: substitution, elimination, everybody's favorite, and graphing. You do need to be proficient in all three, because sometimes on a quiz or test I might say solve by substitution, solve by elimination, solve by graphing. Sometimes it might say pick the method of your choice, and you can do whatever you want. But just make sure that you can do all three different methods. Today we're going to do a lot of substitution and graphing. And the graphing, we're going to do mostly on your graphing calculators today. So have your graphing calculator handy. So, systems of linear equations. Set of equations involves the same variables, x and y majority of the time. Sometimes they get fancy and use like a and b or u and v, something crazy. I know you love the different letters. A system of linear equations. Each equation's linear, so make a line. We will do some non-linear ones today where there might be a parabola involved or something like that. And of course the solution is the ordered pair that makes each system true. Okay? Do you have to write it ordered pair style? No, you could put like x equals 5, y equals 2. I usually just write them ordered pair style because it's less to write. That's how I'm going to roll. Now, for substitution, you've all done this in Algebra 1. It's nothing glamorous. I would say the difference is we might have a few more quadratics today, and you might have to do some factoring. Whatever. Solve one of the equations for x or y. I pick whatever looks easiest. Substitute it in. I solve the equation, get the other answer, and I put number 5 on here just for fun, because I'm sure we're all going to check our answers. Right? Okay. Yeah. Yeah. All right. So first one up. Here we go. Let's slide it down here. Solve the following using substitution. Now I know you look at that and you want to use elimination because the y's cancel, right? We could do it super easy, but it says substitution. So I'm going to pick one of the equations. I'm going to solve for x or y. I'm just going to do the bottom one for x because I have room to write under it. That's my only rationale. So I'm going to add y over. You can pick any equation, any variable to solve for. I just pick what looks easy. Then I'm going to take that expression and substitute it into the other equation. So I'm going to rewrite the top equation as y plus 2. We still have the plus y and the equals 4. And of course, let's just solve that now. I'm going to combine my like terms, y and y. Let's subtract 2 over. Piece of cake, y is 1. Okay, with no work in your head, you should be able to get x. What's x? 3. Just back substitute, plug it in, 1 plus 2 is 3. So I don't care if you leave your answers like this, or like I said, ordered pair style. A lot of times you'll see like textbooks, answer keys, ordered pair style, because especially when we get to graphing, what's significant about 3, 1 is if I graph those two lines, 3, 1 is where they're going to intersect. And that's what we're going to show you in your graphing calculators coming up. All right, threw one at you with some fractions, because I know your love of fractions. Sarcasm. I don't mind the fractions if you really hate them with a passion. Okay? Passion. You can clear them out. So, I'm guessing most of you will want to clear them, so let's do it. So I'm looking at the top equation. I'm looking at the denominators 2 and 4. Fancy phrase here. Least common multiple of 2 and 4 would be 4, the smallest number they both divide into. You could times this whole thing by 4. So then you're going to have half times 4. That's easy. 3/4 times 4. 4 times 10. Same equation, different forms. 2/4, 1/2, 3/6, all the same thing, just different forms. Now, the bottom equation only has one fraction in it. It really doesn't freak me out too much, 3/4. I'm just going to leave it. If you hate it, you could multiply by 4. But I'm going to tell you this. This is just one of those problems you can't avoid having to do a little fraction work with it. It's just going to be there. So I'm going to leave it. Because I'm looking at this, I'm like, okay, I think I can solve the bottom one pretty easy for y. I'm going to add y over and subtract 4. So I'm going to rewrite this as y equals, add y over, 3/4 x minus 4. And we're just going to have to deal with substituting this in. You might, I'm just going to be honest, want your calculators because the answers are pretty bad fractions. You're welcome. Okay, 2x, 3y, but we're replacing y with 3/4 x minus 4, and then equals 40. Good. Okay. Now we're just going to do the math. We're going to distribute, combine like terms, all the good stuff. So 3 times 3/4, 9/4. 3 times 4. Easy enough to add the 12 over. Start with the easy part. Now, I like fractions. They don't freak me out. 2 is equivalent to 8/4. 8 over 4 is 2. So I'm thinking about that as 8/4 plus 9/4. Okay, we need to get, of course, x by itself. You have your calculators. You could use your calculator. Or if we're going old school by hand, I would just multiply by the, yeah. I gotta sneak it in. Okay, I know I'm over 17. What's 52 times 4?
It's 208. It is 208.
I giggle because that's your answer for x. It doesn't simplify, it doesn't reduce. I said you get some bad fractions on this one. You might need your calculator. Now, I would probably do this on my calculator because we need to get y. So I have to do 3/4 times that crazy answer for x, and then minus 4. And for sake of time, I'd probably just punch that in my calculator. You do get a bad fraction for this one, not as bad. What do you have for y? You got it. So you will get some fraction answers. You know I love a fraction. Don't let that scare you. Never, ever scare you. So these to me are like two very basic substitution, nothing glamorous style of problems. You just had a little bit of fraction work. So let's step it up a notch and take a look. Not that much more scary, but notice the top equation, you have a squared in it. You have a quadratic, and then we have a line at the bottom. So I'm just thinking to myself, we're going to have just a touch more work. Now, same process here. I'm going to solve an equation for x or y, substitute it in. Pro tip though, which equation looks easier to deal with? The bottom for sure, okay? Always start with the non-squared, the non-quadratic equation. So I'm going to solve the bottom one probably for y. We can just add x over. That seems easy enough. And I'm going to substitute that into the top equation. So let's rewrite the top one, x squared minus x minus y. Be careful on y, because we need to subtract this entire, can't write and talk. We need to subtract this entire expression. So you really need to subtract both of them. So just be conscientious of your signs, always. So let's subtract, see what it looks like. So I'm going to have minus x, everybody gets that right, minus -1. I'm going to combine my like terms, minus x. What really happens to the ones? Okay, all right, that's cool. So we equal what, really? Which doesn't scare me. Now, quadratic. We know lots of ways to solve quadratics in here. Flashback to chapter 1, everybody's favorite. Factoring, completing the square, quadratic formula. Easiest, of course, factoring. This factors. What can you pull out? X. Let's take a greatest common factor, x, out. So my two answers for x, got it. Now, this one, I would definitely probably, the easiest is write my answer in ordered pair style, because I want to know what specific value of y pairs up with 0 and what specific value of y is going to pair up with the 2. So I'm going to put the answers in ordered pair style. Okay, so if I put 0 in for x, 0 minus 1, I got it. And if I put 2 in for x, 2 minus 1, got it. So I need to know like what numbers pairs up with what numbers when you have multiple answers. So I think it's easier to do ordered pairs. And if you think about this, all it is you have some sort of parabola intersected by a line. That's why there's two different solutions for this one. Okay, let's do another one of this style. Which equation looks easiest? Where are you starting? Top, and I'd solve for x or y. What do you want to do? Probably y, yeah, just add x over. Okay, so we're going to substitute that in for y. So x squared, x plus 4 equals 3. So let's set it to 0, of course, every time we have a quadratic before we pick what style we want to use or method to solve it. We're going to have a 1. I always like factoring. Of course, it's the easiest. What multiplies to 1 and adds to 1? It's not going to work. Factoring's out. Pick. Do you want to complete the square or use quadratic formula? Complete the square. Okay. So what's the trick? I hesitate on completing the square. Here's why. Here's why. I don't mind it. I can do it. I love fractions, as you know. But if you complete the square, you have to do half a b. Half of 1 is what? And then square and add it over. It's going to be a lot of fractions.
Quadratic.
So we could go old school quad form. And plus, then I get to sing it. X equals the opposite of b plus or minus the square root b squared minus 4ac all over 2. And I'm done.
That's the answer.
Why am I done? I heard it. I can't square root a negative. 1 minus 4, negative 3. I can't square root a negative.
Yeah, how's that? Wait, the square work out.
Woo! Now, if you had to graph it, would they meet?
No.
No, they don't have to meet. That happens. All right, good deal. Love it. Okay. I don't know why, but every year, like this style, it's easy. I promise you it's easy, but sometimes like weirds kids out because they're both solved for y. Don't let that scare you. Yeah, just substitute. I'm just going to substitute this in for y.
Mrs. Pryor,
Yes, sir.
I know there's not word problems on the last day.
There sure are. Sure are. Get excited. All right, as always, I'm going to set it to 0. I love the enthusiasm, Alex. Luckily, this one factors. Avery already said, let's take a 2x out of GCF. And what are your two answers for x? 0 and... Now, because we have multiple answers, I'm going to write them ordered pair style, so I have specifically what goes to what. All right, if we put 0 in, what's negative 0 squared, really? 0. Okay, careful here when we put 2 in. What's that going to be? Good. So you would have, if you graphed that one, they're both quadratics, both equations, you'd have two parabolas that intersect in those 2 points, okay? So again, nothing tricky, but sometimes that one just weirds people out, so I'm going to do one like that. All right, let's take a look. You probably, hopefully, know how to do this in your graphing calculators. I'm going to pull up my calculator here to show you. Unfortunately, I'll try not to complain about Texas Instruments. Remember, you have to have them y equal, so you might do a little solving for that. We're going to graph them. Notice my lovely screenshot. You hit second trace. It's at the top of your calculator traces, and make sure you want number 5. That's what we're going to do. So, in a sec. A little more vocab. Now, we've already talked about this. Just be aware of how the graphs could look. So for a system of linear equations, you could have one. Notice it says linear on this one, not quadratics or anything else. 2 lines could mean one place. So intersect at one point. We could have infinitely many solution where you really have the same equation, the same lines. And of course, you could have the no solution where the 2 lines are not intersecting. I needed a longer blink there, clearly. All right, so next one, we are going to graph in your calculator. So the only thing we might have to do is make sure they're solved for y. Which, of course, the first one is pretty easy. I mean, the top one is. Probably don't even have to write anything for the bottom because you can mentally subtract x over. I hope we can. All right, pull up your calculator. Let's clear my matrix stuff off from last hour. Type them both in. Of course, we should all know ln is over there on the left-hand side. And then make sure you use the negative key for the x in front of x. If you use subtraction, it will get angry at you. Now, I have no idea what my window's on. You know, I've been using this for trig. So I'm just going to hit zoom 6. Remember, we'll always put you on the standard 10 by 10 if your window gets off. Now, looking at it, I'm like, Looks like they need it 1 0 if I had to guess it, but I want to make sure it's not a decimal. We want it as accurate as possible. Calculator does it for you. You're going to hit second trace, and you're going to do number 5. So I don't even see my cursor on my screen right now. I'm just going to like right arrow. Oh, there he is, pops on. So he's on the blue curve. I'm just going to have him close to the point. He doesn't have to be right on it, close to it. Hit enter. Automatically jumped into the red. Hit enter. Nobody wants to guess. That's just plain stupid. And my thoughts of 1 0 was correct, but I want to make sure in case it is a decimal. Got it. All right, B, we've got to do a little bit of work. Neither of those equations are solved for y, so let's do it. I'm going to add y over subtract 3. So we're going to have x squared minus 3. Same on the bottom. We could add the y, subtract 1, so x minus 1. So right away, I'm thinking this one's probably going to meet in 2 points because you have the parabola and a line. So I'm thinking this might be a two point. We'll see here. So I'm just going to clear this stuff out. X squared minus 3, x minus 1. Let's see if my hunch is right.
Your hunch was correct.
Okay, looking good. We do need both ordered pairs. Now I could maybe kind of ballpark them on here, but again, I want them as accurate as possible. So I'm going to do second trace, number 5. Doesn't matter which point you do first. My cursor there is kind of close to that left intersecting point, so I'm going to get them a little closer. Enter. Goes to the red for you automatically. Nobody wants to guess. So -1, -2, there's one of our intersection points. And then, of course, you just have to repeat that process for the other one. Second trace, number 5 again. And now I have to right arrow him. I got to get him closer to the point. Good enough. Enter, enter. Hit me. 2, 1. Got it. Glad we don't have to draw the graphs by hand. Any questions, any problems with your calculators? All right, let's do Alex's favorite. Word problem. Okay. Now I am sure we are all going to do this full process for our word problems. Identify the variables. I'm sure you're all going to write out what x and y stand for. I'm sure of it. Set your system of equations up, and then solve it, interpret the results. Okay, let's get to it. This is the best. This is my favorite one. This one's a decimal answer, which I can't remember. Let me grab my phone here. Oh, yeah. I know. My old age, Avery. Okay, are we ready? I love this one. An airplane flying into a headwind travels the 2,000-mile flying distance between 2 cities in 4 hours and 24 minutes. On the return flight, the same distance is traveled in 4 hours. Notice, less time on the return flight because you were flying with the wind home. It matters. Find the ground speed of the plane and the speed of the wind. Assume both remain constant. Okay, I'm going to get fancy. I'm going to define my variables. I'm going to do the whole thing. I'm going to do x first and y. So they want to know the speed of the plane and the speed of the wind. So I'm going to do speed plane and let y be the speed of the wind. Now, before we get to the equations, okay, because I'm still thinking about my variables. So headwind. If you are flying into a headwind, does that speed you up or slow you down? Slow you down. Slows you down. So if we're with the headwind, we got to think about our speed. It slows you down. So you want to take the speed of the plane and subtract the speed of the wind, because it's going to slow you down. It's awful. Now if you were flying with the wind, everybody likes with the wind. If you are flying with the wind, speed you up or slow you down?
Speed you up.
Speed you up. So you're going to add the speeds together. Hang on, Elliot. I don't know what's happening back there. Now, to do our equations, we're going to use an old school formula because we've got distance up there, 2,000 miles. We've got time, and rate is the same as speed. So we're going to use our old school distance equals rate times.
That's a good question.
Time.
Oh, I know.
Alex, no, you did not.
You're all learning right now.
All right, so I'm just going to label my equations so they look super fancy. Now, for both equations, easy question, what's the distance? 2,000. That doesn't change. The way there, the way home, you go 2,000 miles. Got it. Okay, rate. So I'm going in order of the problem of how you're flying. You're in the headwind first on the way there. So my speed with the headwind, where it slows you down, I'm going to use x minus y. And the time for that, oh, I don't like that. It's 4 hours, 24 minutes. I don't like it because you're in different units.
Yeah.
You could go seconds, which seems a lot. Or I'd maybe just convert 24 minutes into an hour.
Oh.
How much of an hour is 24 minutes? 24 over, how many minutes in an hour?
40%. Yeah, 205.
Oh.
So I'm going to put the time going there is 4 hours,
0.4.
so 4.4. Okay, so that's our equation on the way there. Headwind, slowing us down, rates are subtracted. Now we're coming home. Distance is the same. We've sped up because we get to go with the wind on the way home. So that's why we're adding the speeds together. And it took us only
4 hours.
4 hours. Got it. Okay, you have some choices here on solving this, okay? Obviously, I'm still using substitution. At first glance, I'm like, oh man, I got to distribute those numbers out. You could totally distribute them, but distribute and cancel them never do anything for you, really? Don't love it. I would probably just divide them off and get rid of them and then look at the equations, okay? All right, so if I divide 2,000, this is why I got to look at my cheat sheet, I can't remember. If I divide 2,000 by 4.4, I punched it in earlier, it's about 454.55. So I just divided that off. I divided 4 off. I didn't need my calculator for that one. Okay, and now there's our black equations, boring, substitution. Let's solve them. Do you want to solve the top one for x or y? Or, well, I guess we could do either. They're both easy. Yeah, let's do the top one for x and plug it in the bottom. Doesn't matter. It's going to be pretty easy. So I'm going to add y over. So 454.55 plus y. And then I'm going to substitute this in for x on this guy. So let's rewrite the bottom one. 500. I'm going to put in the 454.55 plus y. So that's my expression for x. I still have the other plus y. So I have 2y. We'll subtract it off. You're going to solve it.
What is y?
See what you get.
Oh, and you got it.
What?
You got it.
Oh, and calculator go.
Oh, come on.
I don't even know what I'm supposed to do.
No
Oh,
pressure.
come on.
Subtract 454.55 off, right?
I hate
And
this.
then divide by 2.
22.725.
Let's just go, let's round to the 10th. Let's go 22.7, did you say?
22.
Which makes sense to me, because remember, that's the speed of the wind. Doesn't that seem like a rational speed for wind? 22 miles per hour, 22.7 miles per hour? Okay. Now, speed of the plane. So back substitute that in. You're going to obviously get a bigger number. Remember, the two speeds should add to 500. That's probably the easiest way to figure it out. You put 22.7 and subtract off from 500. What's the speed of the plane? 77.
77.3.
Got it. Does that seem logical for the speed of the plane?
That's fast.
It is fast, but planes fly fast, and I can't wait to be on one to the Bahamas in a few short weeks. Okay, Elliot, what can I do for you?
I wanted to know, does it matter what you assign, what variable?
Nope, I could have them switched around. I'd just be conscientious down here that I have them switched around.
So you're, as long as you're consistent.
Yes, yes. Consistent's the word. You got it. All right, that is the worst word problem of the day. Let's do some easy ones, okay? All right, here we go. Now, let's have an honest talk. Honest talk.
I'm having
Owen, honest talk. How many of you actually are gonna write down X is the speed
Not
of
me.
Okay.
None of them.
Kale, so
Kale,
yeah.
no.
How many of us are actually gonna define the variables? Do you want me to just skip it and get to it?
I honestly think I did.
Let's just get it going. Let's
Okay,
get it rolling.
alright, let's get it going. So, a total, adding, $12,000 invested in 2 funds. I'm gonna use X and Y for my funds, of course. One's paying 9%, one 11%. You get much in yearly interest. How much is invested at each rate? Okay, so we're gonna talk about banking here for a little bit. Hopefully we have some savings accounts or we know how money works a little bit. Banks, of course, pay you interest when you have money in their bank that they can loan out at a higher interest to people. Now, interest always goes with the percentages. The percent yields how much money in interest you get. Like your savings account, you probably get 0.0003% on or something ridiculous, okay? So, 2 equations. First, I'm gonna do one about the total amount of money we're investing. We are totaling to 12,000. Now, I don't know what the split is on that. I don't know if it's 10,000, 2,000, 5,000, 7,000, 6,000. I don't know. That's what we're figuring out. But I know if I add the funds together, it should make $12,000 total dollars in whatever combination it's going to be. And then I'm going to attach the percent sign. But notice I put it as a decimal. I don't have a percent key on my graphing calculator. 11%. And we made an interest 1180. So the setup of the equations is obviously the most important part. You have to remember, and you're going to see more of these money problems, percents always go with the interest. Clearly the top equation looks easier. I'm going to solve it for, I don't care, X or Y, and we'll substitute it into the other one. X, Avery says. And then we're just going to substitute this guy in. Okay, for the sake of time, I'm just watching the clock because I want to give your test back before the 4-day weekend. Can I just give you the answers for these? You can finish solving them, I'm assuming. Okay, so X is $7,000. You end up with, and that was at the 9%. And clearly, if X is 7,000, what's Y turn out to be? 5,000. I trust you can do all the substitution and distributing and solving, etc. It's the equations that are the key. All right, last word problem. Let's just set it up. Take a minute and read it. We'll start reading it aloud. It's for a school fundraiser.
Let's live it like somewhere warm.
You're
not selling
very common, so.
Yeah, but like you're not selling boxes of oranges in Illinois. It's like Florida stuff. It's called random shit. Girl, you're selling boxes of oranges.
Oh my gosh.
They have to be like some more chocolate.
All right, so we are writing, or I should say you are writing, one equation for Danielle, one equation for Mark.
D and M.
So D and M. Set up an equation for Danielle. Set one up for Mark. All right, what's our Danielle equation?
2x plus 6y.
Yes.
Or 6.
Got it. Okay, what do you got for old Markarooski?
What?
What do you got?
12x plus 2y equals 196.
Got it.
Gold star, Avery.
Thank you.
Gold star.
Okay. Obviously, before I do anything, here's a pro tip, especially if you're on a no calculator part of a test, which those numbers are kind of big. I don't know if I'd be that mean to you. I would divide all of these stuff by what? 2 before I even start doing some substituting or anything. All right, I'm going to trust that you can solve it. You end up with X is 13. Now remember, what does X represent? 13 what?
Small box.
Small boxes. How many boxes? The cost of each box. So $13 for a small box. I'm just going to label. And how much then? The large ones turn out to be 20.
$20 for a box of oranges.
Groceries are expensive, people.
We gotta be somewhere chocolate.
I mean, the price of eggs is ridiculous. Groceries are expensive. True, man. I regret giving away all those eggs over the years for my chickens. I should have been charging. Okay, so I trust
Yeah.
you can handle that.